This is Algebra 2 with Trig, working on Unit 6C, primarily solving logarithms. This is our review. We're looking at really the property of logarithms, and we're going to break the 40 up into log base 3 of 5 times log base 3, times 8. So now we've broken this up into two factors that make 40. So now we can work with 5 plus log base 3 of 8. Notice that we chose to use 5 and 8, not 4 and 10, 2 and 20. Other multiples of 40, we use 5 and 8 because those were the two values of logarithms that they gave us up in the given information. So log base 3 of 5 is 1.465. And the log base 3 of 8 is 1.893. So we'll add those two decimals together. And we have 3.358. Here we have log base 3 of 25. Well, how can I use 8s or 5s to make 25? There's really two different ways you can think about this. You can say log base 3 of 5 times 5, and you'd write it twice eventually. Or you can say 5 squared, because that's also 25. We'll use the square so we can use the power property, which means you can bring the 2 to the front. And now we have log base 3 of 5 by itself, so we're going to replace it. Substitute in the 1.465. And it'll approximately equal 2 times 1.465. 2.93. This is a fraction. Kind of like factors. This is a quotient. Log base 3 of 8 minus log base 3 of 5. So we'll take our 1.893 minus 1.465. We have 0.428. Here we're going to use some of the same type of properties. We're going to expand. That means we're going to write more logarithms. So we're going to say log base 5 of 25 plus log base 5 of x. Now what is the log base 5 of 25? 5 to what power makes 25? 5 to the second power makes 25. So this logarithm is worth, to evaluate it, it's a 2. And that's as far as you can expand it. Here we're multiplying two values. So that means we're going to separate it with addition. So you write the logs twice. Then we take our exponent and write it in front. So that's 2 log base 2 of x plus 3 log base 2 of y. Here we have log base 3 of 3 plus log base 3 of the square root of x. Because 3 times the square root of x can be separated, since they're multiples, they can be separated using the product property of logarithms. 3 to what power makes 3? This can actually be calculated, so that's just the value of 1. We can write a square root with an exponent of a half and put that in front of its own logarithm. That's as far as you can go. You cannot say 1 plus a half is 1 1/2. You cannot do that. Now we're condensing. Now we're going the other direction. I don't see any values in front of the logarithm, so I don't have any exponents. I see a plus, so that means I'm going to multiply those two. 4 times 3 minus log base 2, or it's log of 2. It's a common log. So this is log of 12. Minus means divide by 2. You don't write the log twice there. You only bring the 2 underneath the 12. Here we have a value in front of the log, so we write it up as an exponent. So that's 7 squared. Log base 8 of x to the half power. Seven squared is 49. The plus means we're going to multiply two values together. X to the half power is the square root of x. So this is the natural log of x squared minus natural log of y squared minus natural log of z. Minus tells us we're going to have division. So x squared divided by y squared. Another minus tells us that that value, z, is going to go into the denominator also. We're going to do our inverse. So we first write it f of x is y. Then we're going to switch our x and the y. Now we're going to be able to write this in logarithmic form. So 4 to what power equals y plus 2? Then we subtract the 2 across, and we should write our final answer as f inverse of x. That's a logarithm. A logarithm's inverse is exponential. The inverse of exponential is a logarithm. Start out with y. Then we're going to switch our x and the y. Add the 9 across. Now we've isolated this exponential. That means now we're ready to solve for an exponent. To solve for an exponent, we need to use a logarithm. So we use a logarithm with a base of e. That is considered a natural log, ln. Natural log of x plus 9 equals the exponent. Then we add the 3 across. We cannot call that 10. We're going to subtract over the 7. We'll divide by 2. So I'd write that as a half. X minus 7 equals 5 to the y. Then we can call this log base 5, because this is an exponential, solving for an exponent, of we could distribute this in here and call it half of the x minus half of the 7. Equals y. It's better to write f inverse of x. Change the base formula. Log of 18 divided by log of 6. Gives us 1.61. Log of 38 over log of a half. Negative 5.24. So we can say log 128 divided by 3. You could separate this. You could call this log 128 minus log of 3. That would calculate it out. Same amount. Log of 5. 2.33. Okay, good job with the first side. Now, if I'm going too fast for you, I would definitely encourage you to pause the video, work out some of these problems on your own, come back and watch me work it out. Notice the bases are the same, so we really don't need the bases. It's taking the logarithm of both sides. We're just going to have our exponents left over. So we add our 3w over. Leaves us w minus 1 equals 0. Add the 1 across. And we get 1. Here we do not want to say 8 squared. This is why it would be good for you to be working on your own. Pause the video, work this out, and then see how I'm doing it. We wouldn't say 8 squared. We wouldn't put a square on the 8 to make it 64. We need to make the base 8 and square it to be sure that this still equals 64. You don't want to change the problem. Now the bases are the same. How are we going to handle here? Think about it. Now some people make the mistake and they think that they want to cube the half, because a half times a half times a half is going to equal 1/8. But then you've changed this value. What we're going to do is call this 1/2. But if we raise it to the third power, this is really still 1/8. 1/2 times 1/2 times 1/2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And we're going to take the 1/8, which is this, to the second power. Now the bases are the same. So we're going to have 3x plus 4, and we're going to have 3 times 2, which is 6. first thing we do is divide. We can reduce that. Now my exponential is all by itself. I'm looking for what the exponent equals, so I need a logarithm with the same base of 8/3 equals 2w. This is a situation I need to know what log base, well, essentially 10, the common log of 10 over 3, 8 over 3, sorry, 0.425. It does say 596. That means we round the 5/9 up to a 6. But that's really irrelevant because when we divide, we're not going to divide this decimal. We're going to divide this decimal divided by 2. And we get 0.21298. The 8 makes that a 3. So it's approximately 0.2130. Here, we do not have the same base on both sides, but I have to collect their like terms. W is a little big. This is 4 to the W plus 8 equals 22. I can't get the bases the same. I want to solve for the exponent, so I need to use a logarithm with a base of 4 of 22. Now we could figure out what this log base 22 is. Log base 4 of 22. We could use the change of base formula. So that is log of 22. You have to close the parentheses. That gives us 2.22. Now we subtract 8. That gives us negative 5.77. Because the 8 is 5 or bigger, that makes the 2 become larger. Need to divide by 2. We could call that 9.5 would be fine because that's the exact answer. I'm solving for an exponent, so I need a logarithm. So the natural log, 9.5. So we're going to subtract the 2 and divide by the 5. So the G is going to approximately equal 0.0503. We have a 5 or bigger, which makes the next number larger. Here we're determining how long that'll take. So monthly tells us that we're going to use the formula A equals P 1 plus R over N, and T. That's the compound interest. We want to reach a balance of $650 when we deposit $420 with our interest rate of 0.045. We're compounding monthly, which is 12. Now we can divide by 420. Those cross out. We have 65 divided by 42. Now remember, we're going to still work with the real answer. 1.5476 equals this guy. So it might be best to be sure that we keep using this fraction. Since it doesn't break down, let's keep using that same fraction. And we don't have to worry about the decimal right now, because this is going to be a decimal enough to work with. That's 1 plus 0.045 divided by 12. We want to divide the 0.045 by 12 and add it to the 1. Now we have the exponential all by itself. So we're going to say log base 1.00375 of 6542 equals 12t. That means we're going to do the change of base formula. So log of our fraction divided by log of our base, just like we did earlier with easier numbers. And we're going to divide that by t, well, actually by 12 to get t by itself. And that gives us 9.72. That is 9.72 years. To calculate annual, we don't need the n. You could still use our compound formula and just put a 1 in for n. Totally work. That's the same thing we have here. R divided by 1 and t times n. So very similar to what we did before. We're going to divide. Then we'll write our logarithm. And we'll do our log of 65 divided by 42 divided by the log of 1.045. So this is going to take a little bit longer because we're not compounding it as much. Not a big difference, but longer. And for continuously, we use the PERT formula. We still want to be having $650, and we're starting with $420. The interest rate is still 0.45 times t. So we'll divide it across, simplify it. We've done that a few times. We have our exponential by itself, so we're going to write a logarithm. This time the base is e, so we use natural log. So the natural log of 65 divided by 42 and we divide by 0.045. Gives us 9.7 years. So you can tell that that's a little bit less than here because we're compounding it more. Compounding it continuously compared to monthly. Annually is only compounding it once a year. Then we have some solving. We're adding, so we're using our properties of logarithms. I re-changed the order here because x times 3 is the same thing as 3x. Now I'll write exponential form. Here our logs are the same, so we write 5b squared plus 140 equals 55b. We're going to subtract the 55b across because we have two different types of b's. We have a b squared, we have a b, and we also have our constant. So we're going to divide by 5. So 5 goes into that 2 times, 4, so 5 goes into 48 times. And we can factor that apart. So that's x minus 4, x minus 7, that multiplies to be positive 28, that adds to be negative 11, and we use the zero product property. And in both cases, a positive b is going to give us a positive number. Positive b will give us a positive number. Those are both real answers. So now we've got the logarithm equaling an exponent. We need to get inside the logarithm, so we're going to have to turn this into an exponential. We use e because the logarithm we have is ln, which is a natural log. It has a base of e. So using our calculator, we can do e to the negative 1 power. Doesn't really matter what you write down there because we're going to divide that whole thing by 3. Want to do it to the previous answer so it's very accurate. So we have log base 5 of 2 plus log base 5 of x squared equaling log base 5 of 18. Adding means multiply, so I have log base 5 of 2x squared equals log base 5 of 18. Here we're going to multiply across, so we get 2x squared equals 18, divided by 2, x squared equals 9. Take the square root. And we have plus or minus 3. But we notice that the negative 3 would be extraneous. So x equals 3 is our only answer. The extraneous solution would be our x minus 3. We'll get rid of that plus. We'll just call it minus 3, and that's extraneous. The positive 3 is the real answer. All right, last one. Look at this crazy problem. We're solving for a base. Well, let's try to bring our logarithms to the same side. Move your half to the other side. I'll write it as a fraction so I don't have to worry about decimal points. This is minus. So minus implies that we are going to write a fraction. That should be 81, not 18. Now we have the logarithm that equals a value, equals the exponent. So this is x to the half power equals 81 over 27. Well, I know that 81 goes into this, or 27 goes into this thing 3 times. And then we'll square both sides, and x equals 9. So base of 9. There we are, everybody. Good luck.